Yeah, so let's take a look at our last topic for the day, which is network address translation. Okay, so what basically does it do? Well, the most common use of network address translation is where we have a corporate network which uses private address ranges, and we need to translate the source addresses that are going out onto the internet from the private address into the public address that is going to be used on the public internet. That is the most common use of NAT, and as we will see shortly, that is actually referred to as PAT, port address translation, or really NAT with PAT. So we're translating the network address or the IP address as well as the port address. So we'll take a look at that shortly, but that's not all there is to NAT. There are other things that NAT can do, which we will take a look at shortly. And there is also, actually, which is not really going to cover it in this lesson, but I'll just mention it, there is also IPv6 NAT as well, which pretty much does or can do everything that IPv4 NAT can do, but what it can also do is it can translate IPv4 addresses to IPv6 addresses. So we can have IPv4 addresses going into IPv6 addresses with IPv6 NAT, and it can of course translate them back the other way as well. So let's get into this and take a look at what NAT does and how it works. So we're going to look at the purpose and functionality of NAT and PAT, describe NAT processing, configure source NAT, which is probably the most common use of NATing. We're also going to configure destination NATing as well, which you may have heard referred to as port forwarding. Who's ever heard that term? Port forwarding. Okay, so port forwarding is actually destination NATing. So we'll get in and we'll take a look at that. We're going to look at configuring static NAT, and we'll look at how to monitor NAT. So, overview of NATing more generally. So here we have our very typical use of NATing, where we've got a private address range and we've got a public address range, and we are doing source NATing. So with source NATing, we start off with one source address being private, and we end up with a public source address, which then of course goes out onto the internet. A few things to note here is that the source port is also changed as part of that process. The destination port is not changed. We're still using protocol 80 HTTP, and we're still using 6 in our transport layer, which is TCP, of course. All right, so
the source will change. All right, when it's coming back.
Yeah. So actually, this is it going out. So it starts off as it is there on the left, and ends up on the right. So this is the NATing process. This is actually an example of source NATing, because it's the source address that is being changed. But it's also PAT, because we are changing the port as well. So it's already NAT.
So, but when it's gonna make, so when it's taking the public IP address, the port source is gonna change.
Exactly. So the actual header, the IP header, is rewritten.
But when the router has to convert the public address into the private address, it's gonna get the same port number.
What it actually does is it maintains a table. And it maintains a table of this source port number here with that original source IP address.
All right. For this specific communication.
Yeah, it does. It maintains that table, and it maintains this address the source address, the port address that is translated it to. Okay, so it maintains that. So what happens is the return traffic will come back with a source port of 80 and a destination port of 1025. Going to come back and hit the router. The router will look up the source IP address in the return traffic, which will be 221.1.8.5.
Yeah.
It will then look at the source port. It will then look at its table, and from that it will be able to derive what the original source IP address was and what the original source port was, and it will translate it back again into the original values. So the return traffic will be translated back into the original source values, except of course that will the original source will become the destination on the way back, and the original source IP will become the destination IP on the way back. Okay, because obviously the return traffic has the opposite. Okay, so
you're gonna get a randomly port, but they are gonna keep the information for this specific communication. Okay?
Yeah, it maintains a table. So every time it does a translation, it maintains a table of what was translated, so that when the return traffic comes back again, it can translate it back into the original source port and destination and source IP, which of course on the way back will become a destination port and a destination IP. Yeah, so it does maintain.
This is what it but.
Yeah, it maintains a table, so it can tell what it was by the port number. Okay, that's how it recognises.
This is port address translation.
Well, it's both. It's network address and port address. So often referred to as NAT PAT. Right, so it does both. It's translating both. Yes, but it is in fact the port numbers that it uses to keep track of what was the original IP address. It's actually the port number. Remember, the source port number is a completely randomly generated number.
Yeah.
Right? The destination port is a well-known port, so it's a set port number. The source port is just randomly generated from a huge pool of numbers, and so it uses that to keep a track of what was the original IP address. And it maintains a table of that. Okay, so let's take a look at where this sits in the scheme of things. We've got static NAT sitting there, and we've got destination NATing. Both of those are happening before the route lookup. Okay, so that's important because ultimately, if we're going to be changing the destination address, we need to do that before we look up the route for the packet. Okay, it's the address after NATing. But we haven't talked about destination NATing yet. We will get into that. And then we have source NATing occurring later on. So we have the first static and then source. Okay. So here's the process. Have we got static NATing? Yes or no? If we do it, we'll do a route lookup. If we have no, do we have destination NATing? Yes or no? If we, whatever happens after that, either it does or doesn't, we'll do a route lookup. We'll do a policy lookup. Have we got reverse static NATing? Are we reversing it back the other way? Or do we have source NATing? Okay, so, or do we implement source status and then off the packet goes out the interface? So there are in fact three types of NAT and PAT. There is source NATing, destination NATing, and static NATing. So source NATing is the one that we talked about earlier on, where we have got all these private addresses and it's on a network, and we're NATing those over into usually a single public IP address that we have been assigned by our ISP. That's the most common scenario. So that is called source NATing, because what's getting changed is the source address. It's can be changed from a private address to our public address as it goes out onto the internet. Okay. That is source NATing. Destination NATing usually is talking about when traffic is coming from outside the internet, destined into our internal network. Now we're not talking about return traffic for source NATing. That is not destination NATing. Okay, destination NATing is a different thing to return traffic for source NATing. Return traffic for source NATing is still part of source NATing.
But destination NATing is where we are going to have servers in our autonomous system to provide information.
Yeah. I'll give you an example of that. The destination NATing is, say, we've got an FTP server sitting inside our private network, but we need to have it accessible from outside our network, out on the internet. So if somebody, you sitting at home on your computer, you want to access our FTP server. Okay? So how do you do that? You can't contact, you cannot have any connectivity to a private IP address inside our network from outside our network, because that's not a publicly routed address. Okay, but you do have access to our public address. Alright, and that's where destination NATing comes in that you connect to our public address, and destination NATing takes that FTP traffic, puts it onto our private address of our FTP server, and connects you to our server. That's destination NATing. That's destination NATing. Static NATing is where I'm translating one IP address to another IP address. So IP address A is translated to IP address B. That's static NATing.
I'm missing both ways.
It's just one to one. Can go either way. Usually it goes both ways actually. One way on the outgoing traffic and back again on the return traffic. So they are the three possibilities. The ones that are most commonly used is source NATing and destination NATing. Static NATing is rarely used, but could be used if we need to translate. So one range or one network, you connect one network to another network where we may have overlapping address ranges and so on. We can use static NATing to get out of the problem. Okay, so let's take a look at source NATing. Source NATing, there are three types of source NATing. We have got interface-based source NATing. This is the most commonly used source NATing. The PAT is always performed. Pool-based, where we say, well, we're going to translate these private addresses usually into a pool of public addresses. So there's a pool to choose from, and you just choose one from the pool. Or source NATing with address shifting, where we've got one-to-one mapping with no PAT. So we just map from one private range into a public range, and that is rarely ever used. So the most commonly used is the interface-based NATing. As I said, let's go back to that. So the interface-based NATing is, we say, we're going to translate all these private addresses to the address that is on this interface, whatever it is. And the benefit of that is that you don't have to specify an actual address. You just say, translate those source addresses to the address on this interface. And if the address on that interface changes, not a problem. So what happens is if your ISP comes along and changes your public IP address, your NATing still works because you haven't actually locked in a particular address in your configuration. You've just said whatever's on that interface, and that still works. Okay, so that's the benefit of interface NATing. I've had that happen a few times. I just changed it. I didn't say anything, There you go. At least natting still works. Other things didn't, but natting still worked. Okay. Pool base. Yeah, pool base is where you've got a pool address. So here we go. 2 layer matching conditions. Traffic direction specified from and to, so it can either be from a routing instance, from a zone, or from an interface. So you've got a few ways you can do this. If a rule set overlaps, more specific rule set takes effect. Packet information specified with a match clause, so it includes source address and destination address. So we can take some actions. We can have off, so we don't. We can have pool, so it gets matted to a pool. We can say interface, so we just put it or nat to whatever's on that particular interface. Static NAT, reverse NAT mapping rules take precedence over other rules, and changes to the NAT rule tears down an existing session. Okay, here's a interface source NAT. So enable interface-based source NAT for traffic entering the GE002 interface using the egress public interface address of 1.1.70.5. And there's our configuration. So notice it's under these security stanzas. So it's edit security NAT source. Alright, NAT source. And we have this thing where we create a rule set. It's just called rule set 1. We could have called it rule set and given it a name, something a bit more descriptive than that. But you create a rule set from interface to zone. Now we could have said from zone to zone. Could have said from zone whatever. I could have, like for now we say from zone classrooms to zone untrust. Okay, because we've got a zone called classroom and a zone called untrust. We could say from an interface, from a particular interface. I found that it just works better to me, or for our purposes, it worked better to say from a zone because it includes whatever is in that zone. Yeah? But you can have an interface if you need to be more specific. So then you've got to the zone, and then rule 1A is match source address everything. Right, that's just the default, matches absolutely everything. Then source NAT interface. Right, so any address, any traffic, all traffic arriving or coming from interface GE002 that's going to the untrust zone, all traffic, of course, will match the source address, then source NAT interface will be source NATed to whatever address is configured on that interface.
Source NAT interface is...
What we're saying is you're going to source NAT.
Is the interface that really in my attraction?
So we haven't even specified which interface. We haven't really specified the to interface. The interface that's going to. We've specified the from interface. We haven't specified the to interface. Let's come over to our diagram here. So what we're looking at is this interface, whatever this interface is, that's got 1.1.70.5 configured on it. That's the interface that we are referring to where we say then source NAT interface.
Alright.
Okay, that's the interface that we're referring to. Unfortunately, it didn't appear. We didn't really identify which interface that was in our diagram there, but that's the interface we're referring to, where we say then source NAT interface. So whatever interface is attached to our public internet with 1.1.70.5 configured on it, that's the interface down here that we're referring to, and it means that we are going to source NAT everything to 1.1.70.5.
This is equivalent to the overload NAT that we used to configure in the Cisco device?
Yes, that's the same as what Cisco called overload.
Alright.
Yeah. You notice the word overload just doesn't appear here anywhere, but it's equivalent to the overload. Yeah. Because if you do interface source NATing, it automatically does pack. It's part of that process.
And in source address, can you convert this? Yeah, a second.
Yeah.
In source address, can I specify the IP address of my SAT network, my local SAT network? Instead to write the default.
No. Well, in source address, yes, you can specify a range of addresses there in your source address. So you may have the 10.20.20 network, for example, or something like that, or 172.16.3 network. You can specify that in the source address. You can specify.
Basically, this configuration, if your autonomous system is going to have multiple SAT networks.
What?
It's going to have multiple SAT networks, and they are going to access just this interface to access the internet.
Well, no, because when we say from interface GE002.0, that is a specific logical interface, which really only has a single IP address configured on it. See, so really only. But I don't have to put an interface. I could put from a zone, and then in the zone, I could have multiple networks in that zone, and all those networks, or any of those networks. Yeah. See, I don't have to put an interface. I put a zone there. See, I could have any of those networks that are in that zone would be matched against this source netting policy. So you put a routing instance there as well, which may have multiple zones associated with it, and they will be matched against that configuration. So you can match an entire zone, an entire routing instance in the from, but then you could go more specific if you wanted to say source address, so you could be specific if you just wanted to map some of those addresses for whatever reason. Okay, so the result of that is we've got, this is our show security flow session, and what we see is we've got the incoming address into our netting process is 10.1.10.5, and that's getting translated to 1.1.70.6 over there. Interface GE002, and then we've got out coming in on GE003, so then we've got the address that's going, or the traffic that's going out with a different source address, with the NATed source address actually. Alright, so the show security NAT source summary, here we have the rule set from GE002 to untrust action interface. So that's just the summary of it there. So that was interface source netting. This is pool-based source netting, where we may have a pool of addresses and a pool-based source netting with packed from a trusted zone using a public IP address 107.17.137.229. First, we have to define our pool. In this case, we've only got one address in the pool anyway, so it has a similar effect in that we've got that address in our pool, and we are natting from a zone this time to a zone, matching a source address with a particular parameter, so the 10.1.10.0/24 network, and then we're going to source nat that. So as I said, you can map everything. So now we're natting it to this particular address there, okay, which is our public IP address. So you can do it that way. I like the interface way better, because what happens if your public IP address changes, right? You've got to go and reconfigure the natting. otherwise it doesn't work anymore because you've locked in an address. You've locked in that address at 207.17.137.229 address. You've locked it in. Like if your ISP changes your so-called static address, I had that happen about 3 times, by the way. My static address, so-called static address, has suddenly changed, and you think, why isn't that working? And why isn't my VPN up anymore? Why aren't these security policies working anymore?
When we are going to set up a VPN connection, we need to ask to the ISP for a static IP, a static.
Oh yes, you absolutely want a static IP address if you're setting up.
Yeah, because they can change all the time. Sometimes I have been checking my connection, and I can keep my public IP address for a long time, but sometimes they are changing because it's like a pool.
Yeah, that's because you've got a dynamic address.
You know,
so you can ask for a static address.
For this kind of, we want to start with this kind of communication,
Yeah.
VPN or.
Yeah, VPN, you absolutely need a static address. Absolutely. In fact, for anything really where you're configuring security policies, you want a static address. Yeah. If you're configuring destination NATing, you want a static address.
Can you convert just a minute, the last one? So basically, if my trust zone is going to contain so many SAN networks, this configuration is going to allow just one of the SAN networks to get access to the internet.
It's just going to allow a particular network to be source NATed. Yes, it is. Well, we have to assume that was the only network on in that zone. Otherwise, what would be the point, right, of owning source NATing somewhere?
It's part of the security policies to block the rest of the.
Yeah, maybe it is. Maybe it is just locking out whatever any bogus addresses that somehow get in there. Yeah.
You want to get that just one department is going to get access to the internet. It can be one of the ways.
Yeah, that's true. And that's the result of that. That particular configuration. So by default, PAT is performed for pool-based source NATing. That's the default. The port pool is 1024 to 65535, leaving approximately 64K source translation per IP address. So what we're saying is there's no guarantee the same host will use the same address, but you can configure it so that it will, in fact, use the same address by using the address per system command in your configuration. Okay, so pool-based source NATing without PAT. What you can do here is you can enable a pool of addresses to be used, and when that pool of addresses is exhausted, well, too bad. In most cases, what you can also do though, is you can specify an overflow pool in case the pool of addresses becomes exhausted. So it's possible to actually do that way. So here is an example of that pool-based without PAT, and then we have an overflow pool right here. So pool A, there's a pool of addresses, so port, no translation, so we have to disable PAT, and the overflow pool is whatever address is on the interface. Or we can specify another pool if you want to. From zone to a zone, still matching and still then source NAT. So that's another way of doing that. Of course, your normal way of doing that is just straight interface NATing. That's what we would usually do. As a result of that configuration. Okay, so pool utilization of all addresses in a pool are being used. Further packets requiring NAT will drop. You can overcome that problem by using an overflow pool, and you can set some utilization alarm thresholds to receive an SNMP trap notification if we are running short of addresses. Okay. This is source NATing with address shifting. We have a pool-based source NAT using one-to-one mapping, a range of home addresses to a range of public addresses. And let's take a look at this configuration here. So we have a pool at the top there, pool A. We have a host address base. Enables one-to-one address shifting. And the rule is match source address, then source NAT pool A. Okay. And the result, notice that we're not doing patting, no pat, that particular configuration. Alright, so what is the purpose of source NAT off action? Essentially, we are not patting, we're not doing a pat that situation. Okay, so that was source NATing. Now, what about destination NATing? We kind of give a bit of a description of that at the beginning. So, translation is performed on the destination address, optionally on the destination port number. In fact, quite usually you will do both. That's going to be a normal situation. Is you will do both. This is often referred to as port forwarding as well. Port forwarding is really destination NATing. It's the same thing, just different name, but exactly the same thing. So one type of destination NAT is pool-based NAT. It's one-to-one mapping using pools. Let's take a look at that little note here about work ALGs, dynamically generate and allow incoming table packets entering a private network. Let's take a look at the matching criteria. I'll give you an example of this shortly on our router, but we'll look at this first. Traffic direction specified from clause, either from a routing instance, from a zone, or from an interface. The rule set overlaps, more specific rule takes effect. Packet information specified with a match clause includes source address, destination port number, and the actions include off or pool. If we do change it, we'll tear down the existing session. This is a pool-based destination NATing to server A using a public address of 100.0.0.1. It's interesting. So what we've got is we're using a public address, which is actually different. You might notice it's different to the address that's configured on the interface. That's not normally how you do it, by the way. Normally you would use the public address that is configured on your interface, because when you don't use the public address on your interface, that creates some problems. And we'll get into those problems later on, shortly, actually. Single address with no port translation. Here's we have a pool. Pool A, we've got addresses, we've got rule set from zone, untrust match. Destination address, there it is, then destination NAT pool A. There it is there. So what's happening is traffic is being forwarded or sent to 10.0.0.1, and that traffic is being natted from that public address into a private address inside the network.
What do you mean?
What I'm saying is that it's being the public address is being translated into a private address. I'll give you an example of this on our router. A bit easier for us to understand. Okay. Destination NAT with an address pool. This is where we've got an address pool in the pool A. And with port translation, this is where it's usually used, with port translation. That's the result of that. What I might do here, I might just show you an example of destination and NAT. We'll just look at static NAT. It's pretty basic actually. Just goes from one address to another address, and that's that. So from a zone, match destination address, then static NAT to another address. That's about it. So we've got static natting and reverse natting, which happens automatically. Drop non-translated traffic. This is just a thing we can set up on security policies that anything that does not get translated can be dropped. It's an option. Proxy ARP. Proxy ARP is a thing we use to overcome the problem of the address, the public address, being potentially different or being actually different to the address we've got configured on our public interface. So we've got one address configured on the interface, right? But we're actually forwarding traffic to a different address, which we're then destination natting. The problem there is that how does the router at the other end send a layer 2 packet or a layer 2 frame to our interface? That can be a problem. Can be a problem. Not always a problem, it can be a problem. And the solution is to use proxy ARP, where we actually have a interface name, a starting address, and an ending address, or a single address. And what happens is the source net goes out with a public range, and return traffic needs proxy ARP to come back and to find our actual interface address, our layer 2 address. Alright, monitoring and verifying NAT operation. So show security flow session, we can see incoming and outgoing traffic. We'll look at that shortly. Show security NAT source rule, and we can take a look at a pool, we can look at source NAT summaries, we can configure trace options on our NAT if we wanted to. Okay. So let's take a look at some review questions. Does destination NAT occur before or after security policy processing in the first path packet flow? Ooh, does it occur before or after?
Security processing? Security
policy. Destination NAT. Does it occur before or after the security policy processing? Before or after?
Before.
It does happen before, yes. Because the reason it happens before is because when you're writing out your security policies, you only have to think about the endpoints that are involved in your policies. Okay? Because the packets are already natted before the policy is applied. So they've actually, the addresses in the packets will be the addresses of the actual endpoints that are involved. Does the DNOS operating system support static source natting? Well, yeah. What is the purpose of the NAT off action? Actually, I might just come back to that one, verify that one with you. When is a NAT proxy ARP configuration required? It's when we are sending traffic to an IP address that is different to the one that's configured on our interface. And 3 commands use the static NAT operation. Those 3 commands, so they are there. Show security flow session, NAT source rule, NAT source pool, and NAT source summary. Okay, what I want to do is let's just go and take a look at natting on a router. Kind of help us to understand it a bit better. Let's open up this one here. Okay, let's do just going to look at some configuration to begin with, and edit security NAT. We'll do source to begin with, and let's take a look at what's under here. So we've got a rule set. This is admin to untrust. So we're using zones. So from a zone, which is admin, to a zone untrust, this is the rule. It's just called admin NAT rule. Match source address. So we've got an actual subnet specified there, which is in fact the only subnet in the zone. Then source NAT interface. So that is a very typical NAT configuration, which, as we know, includes PAT. Same deal going for the classroom. Oops, come back. Classroom to untrust. Source address 10.10.40.0. Then source NAT interface. That's all good. Okay, that's about all we've got there. So that's fairly basic, actually, isn't it? Like, that's those two rules. Where it becomes a little more interesting is where we have our destination NATing. Let's just take a look at that. Destination, and we'll do a show under there. Okay, so this is where we've got now a number of pools that have been defined. We've got a pool which is called, oops, come back, a pool which is called FS1, which has got a particular address. We've got an access server, it's got a particular address. FTP's got just one particular address. You notice we've specified ports on these as well. So you put ports on your pool, not just addresses. So we've got a VoIP address, remote access desktop 1. So there's a few things here. Pulse secure, HTTP. So then we've specified our pools. There's our pools all set up, good to go. Then we've got some rule set. It's called port forward from zone untrust, and the rule, this particular rule, is access server, and the matching is destination address 103.96.6.108/32. Now, what address is that? That address is what? That address, let me just show you what that address is. I'll just do a figure out where that address, what is that address? There it is there. That's that address there, right? That is the public IP address that is configured on our firewall. So what we're saying is, if it matches, if traffic is sent to that IP address and it's using port 23, which is telnet, right? Telnet, then destination NAT to the pool access server. Access server is, where's access server? 10.10.40.29. Okay.
This management network, the real one, yeah?
Yeah, this is the real one. So what we're saying is, if you were to telnet to 103.96.6.108, what this destination NATing would do, it would automatically translate the destination address from that to, where is it?
2.29.
Access server 29. Yeah, to the access server. Access server address to there. Okay. So what is it matching on? It's matching on two things. It's matching on, is it that address, and is it using port 23? If the answer is yes to both of those, then it will destination NAT to the access server. Okay, that's that. So let's just finish doing that. We'll do a show. Okay, so that was that first one. Here's another one here. Rule FTP. Destination address exactly the same. This time different port though, port 21. And this time we're going to destination NAT to a pool called FTP. So what are we saying here? What we're saying is if traffic is coming to this public IP address and it's coming in on port 21, which is FTP, then we'll do a destination NAT to this address here that matches pool FTP, which happens to be the address of our FTP server. Okay, so what that means is you should be able to open up a connection to that address on an FTP into that address. Let's see if it works, shall we? Now, I would have to have a security policy that allowed that as well. And I may have a problem doing that from inside my network as well. That could be a little bit of an issue.
Sometimes have trouble to get access to.
Yeah, that could be an issue.
Connect to the ACIT server. Using the VPN connection or using the public address. Both.
Is it?
Sometimes.
Yesterday
it was working.
Might have to check the security policies on that just to see if that's, because not only do you have to have NATing, you've got to have a security policy that allows that traffic through as well. So I might just check that. FS1. There's this is actually a remote desktop protocol, which allows through to address what FS1. This is SIP. This one here allows traffic to get through to our VoIP server. So we've got VoIP traffic coming in from our internet telephony service provider. It will hit our public IP address and be translated through to our VoIP server so that we can receive phone calls from outside. What else have we got down there? HTTP, here we are, HTTP. If I was to HTTP to that address, what would happen? That should work, shouldn't it? Maybe, oh, there it is. There's our ACIT web server. So we have actually hit actually what's happened is we've been translated to an internal web page right there, which matches that address there, HTTP. And if we go back and look at our pool, find our HTTP pool, where's that? Yes, HTTP, there it is there. That's our rule. Where's our pool? Go and find it. It'll be somewhere. There it is. 10.10.40.12. Right there. Port 80. Okay, so we're actually looking at an internal server of 10.10.40.12 when we go ahead and open that page. Okay, so that is our destination NATing. Creating that. It's not really a proper web page, it's just got our logo there. Alright. Okay, so that's destination adding. So you can take a look at that. If you want to go and take a look at our, we'll just exit out of there, like so. Get rid of that. And what I want to do is go show security flow session. And these are some sessions coming up here. What you will see is that natting is taking place. So we have got a source address of, in this case, 10.225, and that has been translated to, where's that going? Oh, that's our destination address. This is our translated source address right there, 103.96.6.108. So that is source natting occurring right there. Original address and natted address. Okay. And there's going to be quite a lot of those. That's only up to 3%. Alright, so there we go. This is actually looking at our session table, by the way. Alright, so that is that's natting. So we looked at source natting, destination natting, why we might want to use destination natting, and looked at some examples of destination natting in action. I should be able to, if I wanted to see if that telnet is working, I should be able to go and take a look at that as well. And I should be able to actually telnet to that address, and there we are, it works. And so what that has done is actually put me through onto the access server, right, which is inside my network. It's an internal device. So again, that's destination natting. That's allowing that to happen working in conjunction with a security policy that also allows that traffic through, right? So you've got to have two. You've got to have the destination natting and the security policy. Both of those have to be configured to allow access through onto that server. Does that make sense? Okay, you've got to have destination natting and the security policy. All right. Okay, guys, so any questions about natting? All good, making sense. Let's just exit out of there. Okie doke. All right, well, that concludes our lesson for today. Thanks, guys.